Welcome to PVS the Tutor. Here we have a question on work energy and power, tutorial number 1. So here's it's a multiple choice question. So let's see what we can do. A car of mass 1500 kilograms moves up an incline at a constant speed. In physics, terms like constant speed are very important. As shown in this figure, the incline is at 12 degrees to the horizontal. What is the power provided by the engine of the car for it to travel up the incline at 16 meters per second? So, it's a very simple question, by the way. So we have the mass, which is 1500. Then we have the velocity, which is 16 meters per second. Then we also have got the angle, which is 12 degrees. What else? Of course, we have here the acceleration due to gravity, remember. So we have the value of g as 9.819 meters per second squared. What our job is to calculate the force F. This force is the force which is moving this car up the incline. All right. So we need to do some vector resolutions here. All right. So if let's say this is the weight. Okay, so here we have the normal force, all right, the normal force, or we can call it N, like that. That's a normal force, right? Well, the weight is like this. Therefore, the weight, all right, mg, but there should be a component which is actually in the same direction as the normal force. And usually this is what we call mg cos theta. And here is mg sin theta. This is the same angle that we have here because these are just alternating angles. All right, now that we have that, all right, what we are looking for. So this force here in the y-axis, right, this one, it's the one which is actually parallel to the force that we are looking for. All right, and they are parallel to each other. So the force that we are looking for, and by the way, this car is going up, all right, and for now we assume there's no friction. Are we there? Meaning these two, the mg sin theta and the force, all right, this means that since this car is moving at constant speed, right, it means that the force which you're looking for, which is the driving force, it must actually balance it. It must actually balance the components. All right, now which component? The component of the car's weight. All right, specifically this. So our F is mg sin theta. Balancing like that. So our force is mass 9.8 sin 12 degrees. Can't punch a calculator. So I'm getting 3059. I'll leave it to one decimal place, newtons. Do you know why we're finding force? Because power is actually force multiplied by velocity, in case you didn't know. So 3059.3 times our velocity is here. 16 meters per second. So let's punch this together. So I'm getting 48948.8 watts. Well, check on the multiple choice questions. We don't have watts, we have kilowatts. So if we divide this by 1,000, all right, we'll be getting something like 48.9488 kilowatts. So we have something closer, meaning you can just round off. and we get our power as 49 kilowatts. There.